Hi, welcome back. This is Professor Ridge, and today's lesson is on section 1.3, linear functions, slopes, and applications. Linear functions. A linear function is just an equation of a line, and we just use function notation for it. So it's no different than slope-intercept form. But again, we're going to write it in function notation. So a function f is a linear function. So again, linear, right? The graph makes a line. Also, if it's we can think of it, it's degree 1. If we're thinking of it as a polynomial. If it can be written as, and again, we're just going to use slope-intercept form, but remember, f of x stands for y for a given x. The y value for a given x. So f of x equals mx plus b. And that should be real familiar to you, right? That's the slope-intercept form. So it's the same idea where m is slope and b is the y-intercept, the y-coordinate of the y-intercept. And they're constants, they're numbers. If m equals 0, the function is a constant function. F of x equals b. So again, y equals b is a horizontal line. That's a constant function. The function's not going up or down, it's staying constant. If m equals 1 and b equals 0, the function's called the identity function. F of x equals x. So again, it's the identity function because basically no matter what you put in for x, the y value is going to be the same as x. They're going to be identical. Okay, so if I put in 1, the output would be 1. If I put in 2, the output would be 2. So y equals x is 1, 1, 2, 2, 3, 3, 4, 4, and you get that line. So if we graph the constant function f of x equals 3, or y equals 3, however you want to think of it, again, it's a constant function because no matter what I put in for x, say 0, f of 0 would be 3, f of 1 would be 3, f of 2 would be 3. F of 0 is 3, f of 1 is 3, f of 2 is 3. And see what you get is a horizontal line, which is the constant function. So it's staying the same. It's staying constant. And then the identity function say y equals x or f of x equals x. Whatever you put in for x, that's what your y value is. So 0, 0, 1, 1, 2, 2, 3, 3, so on. Okay, so 0, 0, 1, 1, 2, 2, 3, 3, oops, a little higher. And that's my identity function, y equals x. Horizontal lines are given by equations of the type y equals b or f of x equals b. Just like we did an example above with constant function. So again, horizontal lines, they're constant functions. So they're functions. Now vertical lines, these are not functions because it would fail the vertical line test. Because basically we're saying for one x you have more than one y. In fact, you have an infinite number of y's. So vertical lines are given by equations of the type x equals some number. And again, note, they're not functions. I used to, as a student, always get confused with this because, you know, when I think y equals b for a horizontal line, well, the y-axis is a vertical line. And so y equals 5, you know, I would get wrong as a student because then I would think, okay, y equals 5, y is a vertical line, so I'd go to 5 and draw a vertical line. But see, the problem is it's not, you go back and you get, here's how I kept it straight is, so if I wanted to graph y equals 5, right? And, you know, I knew it's either horizontal or vertical, so then I would reason through it and remember that a solution to an equation is replacement values for the variable that make it a true statement. So for y equals 5 to be a true statement, the y-coordinate has to be 5. And there's no restriction on x because there's no x in there. But y has to be 5, and x can be whatever I want it to be. So I would just plot, you know, a couple points. X could be 1, 2, or 0, but y has to be 5. So then I go up to 5, and 0, 5, 1, 5, 2, 5. And then I'd see it's a horizontal line. Okay? So that's how I'd reason through it. If I wanted to graph x equals -2, for instance, so -2, I should rewrite it. X equals -2. Again, I'd go through that same line of thought, same reasoning. Well, for x equals -2 to be a true statement, the x-coordinate has to be -2. And the y-coordinate, there's no restriction because there's no y in the equation. So y could be whatever I want it to be. So I put 0, 1, 2. And then I plot the points, -2, 0, -2, 1, -2, 2, -2, 2, and then I would see that that was a vertical line. Okay, so that's x equals -2. Right. So that's how I would keep it straight as a student. So at first it confused me. Again, I told you why. I don't want to repeat the confusion part. So I just reasoned through it. A graph is a picture of the solution set, and for the equation to be true, for this one here, the y-coordinate has to be 5, so see? And then x could be whatever I want it to be, so I just put 0, 1, 2 for x, and y has to be 5, plot the points, and no problem. Okay, and then I can do the same thing for x equals a number. Okay, for it to be true, x would have to be equal to -2. So again, x is -2, y could be whatever I want it to be. So 0, 1, and 2. Alright, let's move on. Alright, so the next thing is slope. So if you recall, the slope of a line, the slope m of a line containing 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. And again, remember, the subscripts are just distinguishing characteristics. They're just to tell you this is point 1, x sub 1 is the x-coordinate for point 1, y sub 1 is the y-coordinate for point 1. Okay, so there's no numerical operation attached to it. It's just to distinguish this is the first point, that one's the second point. Okay, so the slope of m of a line containing points, okay, those are the 2 points, is given by the formula. Okay, well, the words that we associated, remember, is rise over run. So slope kind of describes the steepness of a line, and we write it as a ratio of the vertical change compared to the horizontal change. So the change in y, vertical is y direction. Horizontal is the x direction. So mathematically, the way we figure that out is we say m equals, we subtract the y coordinates. That's the change in the vertical direction. And then we subtract the x coordinates. That's your horizontal change. And notice, the order doesn't matter as long as you make it the same order for the top and the bottom. So whether you do y1 minus y2 or y2 minus y1, it's fine as long as you do the same thing on the bottom, top and bottom. All right. So typically I just do it y2 minus y1 over x2 minus x1, but you could switch it. Who's to say which one's 0.1 and which one's 0.2? So that it doesn't really matter. As long as you don't mix it and put y1 minus y2 on top and x2 minus x1 on bottom. So you can't do that. So it has to be the same. If you recall from slope-intercept form of a line, the slope of a line given by, now we're using function notation in this chapter. F of x equals mx plus b. So just like in slope-intercept form, the m is the slope. M equals the slope of the line. All right? So nothing different there. Oh, I guess I wrote this wrong. Slope of the line given by f of x equals mx plus b is m. That's what I sure wrote. But anyway, you get the idea. So this is kind of like, there we go. Okay, so what I'd like you to be able to do is just glancing at a graph, you should be able to tell me whether it's a positive or negative slope. Now it has nothing to do with where the line starts or ends on my graph here. The idea is you think as you read from left to right, if you start at the bottom here from the left and it's going up. Actually, lines don't ever stop or end, but anyway, it's going up as I move from left to right. That's a positive slope. A negative slope would be if it's moving as you go from left to right, it's going down. That's a negative slope. Zero slope means it doesn't go up or down. That's a horizontal line. So this would be zero slope. Well, if I drew it right, it would be. And undefined slope, that is, undefined slope is a vertical line. Okay, so vertical lines, the slope is undefined. Some books, say, would call this no slope, right? It's not defined, it has no slope, which is different than saying the slope equals zero or zero slope. Zero slope is, zero is a number, so 0 over 1. So you go up 0 over 1, up 0 over 1. Okay, so zero slope is different than no slope. Subtly different, but, right, the lines are totally different. Horizontal, zero slope. Vertical slope is, and just to keep from confusion, we'll say undefined. I almost forgot to do an example of the one up there. Find the slope of the line through these 2 points, -6, -1, and 2, -13. So m equals y2 minus y1 over x2 minus x1. Now, just as a study note, when I was a student, whenever I did math homework, and I was asked to do something like this, whatever, I'd write the equation down and try to write it down without looking at my notes. And, through the exercise set, after I did 5, 6, 7, 8, 20 of these, I would have the formula memorized, but I'd always write the formula down first Again, trying to do it without looking at my notes, and then I would, verify it was right first before I went on to complete it. Okay, but so kind of when I did my homework, I would study and try to memorize these things. All right, so again, this is x1, y1, x2, y2. So I'm going to go negative 13 minus a negative 1 over 2 minus a negative 6. So that's negative 13 plus 1, which is negative 12, over 2 plus 6, which is 8. And that reduces to negative, let's see, we can divide a 4 out. So that would be negative 3/2. Now another thing I would do for just a rough check, I would kind of, with not to like scale completely, negative 6, negative 1 would be right about there. 2, negative 13 would be right about there, and I could see that that's a negative slope. So I would be satisfied that, okay, at least I got the sign right. So you can do that as a check. Okay, rate of change. So I always tell my students, whenever you see rate of change, think slope. Rate of change or just rate. Rate or rate of change, think slope. Okay, so rate or rate of change, think slope. And basically what we're doing is it's precisely that. If you have two data points, the rate of change is going to be the slope between those data points. Okay, so slope can be considered as an average rate of change. So again, rate of change, think slope. Okay, slope can be an average rate of change. To find the average rate of change between any two data points on a graph, you just find the slope of the line that passes through those points. Okay, so simple enough. Okay, so here's an example. The population of Flint, Michigan decreased from 124,943 in 2000 and 112,900 in 2008. Find the average rate of change. So I'm thinking slope. Find the average rate of change in the population over the 8-year period. So we want average rate of change of the population. So we're going to do, so you can think of this as like, if the year, think of these as data points. So the year is 2000, year, population is 124,943, and the second data point is in 2008, 112,900. So we're going to do M equals y2 minus y1 over x2 minus x1. So it's going to be 112,900 minus 124,943 over, let's see, which one? So 2008 minus 2000, which we know is an 8-year period. And then we got to subtract the top two numbers. And that's negative 12,043. And then divide that by 8. And we get 15, negative 1505.375. And that's per year, right? The average rate of change per year. So it's going down by 1,500, a little over 1,500 people per year. So the y coordinate's the population, the people, and the x coordinate is years. See, so that's how you say the year. So it's 1,500. It's decreasing by 1,500 people per year. Okay, so find the slope and y-intercept of the line in the given equation. So again, slope-intercept form, y equals mx plus b, so m is the -2. And then the y-intercept is not 3, it is 0, 3. Okay, that's the y-intercept. Okay, and let's try another one. Now this one, 5 minus 1 half x. Now that's no different than writing -1/2 x plus 5, right? It's the same idea. The coefficient of x is the slope, so slope is -1/2, and the y-intercept is 0, 5. What about this one? 2x minus 3y equals 12. And the slope's not 2 because it has to be in slope-intercept form, meaning you have to get it y all by itself. You've got to solve it for y. So subtract the 2x, divide by -3. So y equals 2/3 x minus 4. So the y-intercept is, or the slope is 2/3. And the y-intercept is 0, -4. F of x equals 12. So f of x equals 12. That would be 0x plus 12. So slope is 0. And the y-intercept is 0, 12. And then if you had x equals 5, well, so it has no slope. Or again, we should say slope's undefined. No slope's it's fine, but I just don't want to confuse you too much. And the y-intercept, well, there's no y-intercept. Okay? And that's not a function either. Okay, that completes the exercises for, or the lesson for 1.3. Go to my math lab, complete your exercises there, and I'll see you next time.